Guys, hope all of us are doing fine. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In this particular discussion, I'm going to look at the measures of central tendency, and this basically is going to be under the concept of the arithmetic mean. Now, from our last discussion, of course, I've done a video on the concept of the arithmetic mean, and in that particular video, I looked at the example of one of the illustrations which we used, of course, in deriving the arithmetic mean for frequency distribution and the arithmetic mean for raw data in that particular order. Now, we are given a specific formula for finding the arithmetic mean of a specific set of data, which can be represented using the x variable with a set of distributions for x1, x2, to xn, and we said that basically the arithmetic mean constituted the sum of the magnitude of items divided by the number of items. And in this case, we are going to consider this individual sets of items from x1, x2 to xn given as such. And therefore, we defined the arithmetic mean as the summation of all the items over x1 plus x2 plus this last item of xn divided by the total number of items given as such. And this, of course, gave us a summary of the representation, which we said was given us the summation between I is equivalent to 1 of all the items divided by the number of items given as such. And this was for the raw data. And we said that in case we have some of the items amongst this distribution occurring 1 or 2 times, this is going to, of course, constitute the concept of a frequency. And therefore, we said that we can attach the concept of a frequency for various distribution of items over x1, x2 by generally representing them that if we have x1 occurring f1 times and x2 occurring f2 times, we can have this general representation to the last item, whereby we're going to see that these are going to appear in terms of xn to fn times given as such, and therefore we're going to use a general formula in trying to represent this is specific of items considering the concept of a frequency. Now in this case, we came up also with a general formula, and of course this was given in terms of the number of classes which we had given in terms of k. Now in this case, our general representation for this second scenario therefore was given in terms of the arithmetic mean is given as I is equivalent from I1 to k of the summation of the product of frequency and the x items divided by the sum of all those frequencies of the various classes given in terms of the summation of fi. And this, of course, gave us a general representation for this specific set of data occurring in terms of classes. Now, in this case, we had said that for us to find this specific arithmetic mean, we can use either the first or the second formula in trying to evaluate that. Now, in some cases, we're going to see that for us to conveniently have meaning from data or a large group of data, we're going to put it into classes which are going to be divisions occurring, of course, in a uniform manner, in a sense that the sizes are going to be the same. And of course, we're going to have some of the, of course, a range of data giving the lower class limit and the upper class limits in that particular case. And that's going to give us a convenient way of trying to represent data. Now, in my right side of the board, I've given a specific example giving the class and the frequency. And that is going to give us a way of trying to find the arithmetic mean for a group kind of data. Now, in this case, I'm going to use the particular concepts which we have looked at from our previous discussion. And this, of course, is going to particularly entailing this second description for the group kind of data which we have given in terms of classes. Now, in this particular case, for such a kind of data, I'm going to include another specific column at this specific point, and this is going to include what we refer to as the class mark. Now, the class mark is going to be the average between the upper and the lower class limit of a specific class. Now, in this case, if we have our first class given in terms of the range between the low class limit of 6 and 10, and therefore this is going to be giving us the total. So for us to find the average for this is going to be 6 plus 10 divided by 2. And this is going to be the same procedure we're going to use in finding the various class marks for the a particular number of classes given as such. So this is going to be 6 plus 10 divided by 2 is equivalent to 8. 11 plus 15 divided by 2, that is going to give us, of course, the product over 26. And that's going to give us the average or the class mark over 13 given as such. So this is going to constitute a column for the class mark of that specific set of grouped data. And the respective ones that we're going to find for the preceding classes are going to be 18 for this one. Now from 21 to 25, that is going to be 23, 28, and lastly we're going to have this one given as 33. So in this case, our class mark is going to constitute specific items for the xi, and then we're going to consider this particular set of frequency given in terms of fi given as such. So this is going to form our two specific set of data, arrange for data, which are going to give us the product, and of course which is going to form our numerator in this particular case. So we're going to find the summation of this one divided by the sum of the total frequencies given as such, and this of course are going to be given in terms of the first one is going to be a multiple of that one given as 280, and we're going to look at the second one. This is 299, 270, 276, 256, so that is going to be 252, and then lastly we shall have the last one given as 198. So basically for that set of data, then therefore this is going to constitute a column of the product of xi and fi given as such, and of course we're going to find the total for that one. The summation of this frequency is going to be 100. And then we're going to have this one, the sum of fxi, ixi given as 1575 given as such. So these two specific products are going to give us the ratio, which is going to be, of course, our arithmetic mean. So in this case, we're going to have this one given in terms of equivalent to 1575, which is the numerator, and then we're going to have divided by 100. So that's going to give us 15.75, which is going to be our arithmetic mean for this specific set of group data. So we're going to use the same procedure in trying to find the arithmetic mean for various range of group data, and that's going to constitute classes and the column for frequency and x, and of course the product between the two, and there of course we are going to use their specific summations in trying to find this arithmetic mean. So I hope that procedure is clear, so that we're going to use it in any case we come across any set of a problem or a problem set which is going to require us to use the same approach given such a kind of a data. So that is it for now, guys. Bye, God bless you. Catch us in our next video.